Hi students, myself Dr. K.S.Rangasamy, working as a professor in the Department of Mathematics. In this lecture video, let us see the topic measure of dispersion in statistics. Now, measure of dispersion gives the scattering of the data. It tells about how the values are distributed in the data set. In statistics, we define the measure of dispersion as various parameters that are used to define the various attributes of the data. There are two types of measure of dispersion. One is absolute measures and another is relative measures. Absolute measure is nothing but it measured and expressed the units in the data themselves. In that absolute measure of dispersion, we have range, mean deviation, standard deviation, variance, and quartile deviation. Relative measure of dispersion is nothing but used to measure the two different quantities with different units. In this, we are having coefficient of range, coefficient of variation, coefficient of mean deviation, and coefficient of quartile deviation. Now let us see range. Range is defined to be the difference between largest value and smallest of the observation. That is range equal to L minus S. Coefficient of range equal to L minus S by L plus S. Now let us see how to find the range of an individual data which is given in this problem. Now let us see the given data is an individual data. Some values may be given that it is taken as a data set. For this data set, we have to find the largest observation, that is 45, and smallest observation is 13. So range is L minus S equal to 32. And coefficient of range is L minus S by L plus S, that is equal to 0.55. Now let us see how to find the range and coefficient of range for the continuous frequency distribution. Now the limits are given and frequency is given. From this continuous frequency distribution, let us find what is the value of last frequency, that is highest interval, and the smallest interval. Then difference between the last and the smallest gives the range of the given distribution, and coefficient of range is as usual L minus S by L plus S, that gives 0.417. Now let us see quartile deviation. The quartile deviation gives by Q3 minus Q1 divided by 2, and coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1. Now let us see discrete frequency distribution, how to find the quartile deviation for this category. Now for this category, let us find cumulative frequency first, then we have to find Q1, that Q1 gives n plus 1 by 4th observation, and let us find Q3, that is 3 into n plus 1 by 4th observation. Now let us see one example. Find the quartile deviation and coefficient of quartile deviation for the following data. Now some discrete frequency distribution is given. Let us see the steps how to find the quartile deviation. Now from the given data set, we have to find cumulative frequency first. Then here the cumulative frequency is 548. Just adding that previous frequency with that corresponding frequency, so that I will get 61 plus 364, 132 plus 64, 196. In the same way, then finally we will get the cumulative frequency as 548. Now let us check what is Q1 value. Q1 equal to n plus 1 by 4th observation. Now cumulative frequency is 548. 548 plus 1 divided by 4, that gives 136. Now in the cumulative frequency, the 136 nearer value is nothing but 196, and the corresponding observation is 40. So cumulative frequency gives Q1 equal to 40. Similar manner, Q3 equal to 3 into n plus 1 by 4th observation, that gives 548 plus 1 by 4 into 3, it is nothing but 408. So a nearer value to this cumulative frequency is 489, that corresponding observation is 60. So Q3 is 60. So the quartile deviation gives Q3 minus Q1 by 2, that gives 60 minus 40 divided by 2 gives 2. Then coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1, that gives 0.2. Next, let us come to the next topic, continuous frequency class. In this continuous frequency class, we have to find the same way cumulative frequency, then Q1 class using n by 4, then we have to calculate Q1 as Q1 equal to L1 plus n by 4 minus M1 by F1 into C. Now how we can find this L1 is the lower limit of the Q1 class. M1 is the cumulative frequency of the preceding of the Q1 class. F1 is the frequency of the Q1 class. C is the length of the interval. Now we can find Q3 class using 3n by 4. Q3 can be calculated as L3 plus 3n by 4 minus M3 by F3 into C, where L3 is the lower limit of the Q3 class, M3 is the cumulative frequency of the preceding of the Q3 class, F3 is the frequency of the Q3 class. Then after that, quartile deviation gives Q3 minus Q1 by 2. Now let us see one example. That continuous case is given. We have to find the quartile deviation. In this continuous case, we see that the first limit is 20 to 29 and second limit is 30 to 39. So we have to make it as continuous case first. Then after that we can find Q1, Q3 class. Then after that we can find Q1 value and Q2 value, so that we will get quartile deviation. Now we can make that distribution limit as continuous case by writing like this. Then frequency, then as usual cumulative frequency. Here let us find Q1 class first. This Q1 class lies in the interval 19.5 to 29.5. Since that n by 4 value is 201, that nearer value for this 201 in this cumulative frequency is 306. So that class is nothing but 19.5 to 29.5. Here the lower limit L1 is 19.5, M1 is nothing but 0 because previous frequency is 0. F1 is 306 corresponding frequency, then C equal to class interval, that is 10. So Q1 can be calculated as L1 plus n by 4 minus M1 divided by F1 into C. We will get 26.06. Similar way, Q3 class lies in the interval 39.5 to 49.5. Since 3n by 4 is nothing but 603, the value which is nearer to 603 in cumulative frequency is 632. So in this case, L3 is 39.5, M3 is 488, that is previous cumulative frequency, F3 is 144 corresponding frequency, C equal to 10, so we will get Q3 equal to 47.486. From these two values, we will get quartile deviation is 10.713 by substituting in this formula, and coefficient of quartile deviation as 0.291. Thank you for watching this video.